Hello everyone, friends. Merry Christmas to those celebrating the birth of Christ and their families, and happy holidays to everyone. Let's look at OWASP mobile risk number 3, which is insecure authentication and authorization. This is one of the most critical risks in mobile applications because it directly impacts user trust, data protection, and the business itself. So you can break it down into authentication and authorization. And authentication is about proving who you are. For example, entering your username, password, or using biometrics like Face ID. Authorization, on the other hand, is about what you are allowed to do after you've been authenticated. For example, whether you can view your balance or transfer money in a mobile banking application. So when these processes are weak or improperly implemented, attackers can gain access to accounts or perform actions they should never be allowed to. Insecure authentication happens when mobile applications allow users to log in without strong verification. And this can include applications that don't enforce passwords, skip multi-factor authentication, or trust-only client-side checks. So attackers exploit this by brute forcing usernames, bypassing login screens, or replaying stolen tokens. Insecure authorization, on the other hand, occurs when an application doesn't properly verify user roles and permissions. For example, if a mobile application only hides admin features in the user interface, but the server doesn't enforce role checks, an attacker can simply call the API directly and perform unauthorized actions. So to prevent this, you need to always enforce authentication on the server side so that you don't need to trust anything on the mobile application. You also need to match the authentication strength of your mobile application with your web counterparts. The same way the web you think is exposed to the internet and to everyone outside there is the same way you should treat the mobile applications. You should use strong authentication factors as well. That includes strong passwords, short-lived tokens, biometrics, and multi-factor authentication. And honestly speaking, anything that only uses passwords and pins is considered right now insecure. And also you need to make sure you don't store passwords or anything spoofable values like device IDs locally. And then for authorization, you should enforce role-based or attribute-based access controls strictly at the back end. And finally, you should assume that all client checks can be bypassed and never rely on what the application tells you about the user's role or permissions. The impact of insecure authentication and authorization can be really devastating, and this includes reputational damage, information theft, fraud, and unauthorized access. So in short, insecure authentication and authorization don't just create security risks, they create a direct financial and reputational damage. So what you need to remember is secure authentication proves identity, secure authorization enforces what that identity is allowed to do. Both must be implemented server-side and should be reinforced with modern practices and be tested continuously. And enough of theory, and now let's get into the demo mode. So we will use our favorite oversecured vulnerable application that has a weak authentication handling, and the bug involves installation of an arbitrary login URL via deep link URL that leads to the user's username and password being leaked when they log in. So the URL can be modified and controlled by the user, and that means an attacker can pass an arbitrary URL to a user in a form of an application and redirect those credentials to their own server. And the rest, as I say, is account takeover and everything that comes with it. So when a user logs in, the credentials and the URL is passed into a login data file that's stored in shared preferences directory. So let's go to the directory via ADB and see what it actually contains before login. When we CD into it and check its contents, we confirm that there is actually nothing inside. Now let's log into the oversecured app by entering whatever dummy email and password and see what happens next. So after login, we check the directory again. Surely you can see the XML file now, and cutting through it, we see that the user credentials we just used for login are actually contained inside. And the login URL is also stored, and it can be parsed as well, but we won't be demonstrating that one here. So you can check on the previous videos on deep links, because we've extensively covered it there. This means if an attacker can control the login URL, then can have the user's credentials sent to their own hosted server. And I hope this at least demonstrates what insecure authentication means. There are going to be other scenarios that you can read about in the wild. I just hope this one helps. And that is it for now. See you, and you're much welcome.